On September 15, 2017, NASA did something that sounds insane. They took a spacecraft that still worked, still had power, still had functioning instruments and flew it straight into Saturn on purpose. It wasn't an accident, it wasn't a malfunction, it was the plan all along. But those final 22 orbits weren't just a suicide mission. They gave scientists measurements of Saturn that had never been possible before, revealing clues about its rings, its atmosphere, its magnetic field, and even what lies deep beneath its clouds. This is the story of how killing a spacecraft on purpose taught us more about Saturn than most of the mission that came before it. Visual: Saturn slowly rotating in deep black space, Cassini spacecraft silhouette in foreground. Why Cassini had to die? Cassini launched in 1997. It took 7 years just to reach Saturn. Once it got there in 2004, it was supposed to study the planet for 4 years, just 4. It ended up staying for 13. By 2017, its fuel tank was nearly empty, and that created a real problem. A dead, uncontrolled spacecraft drifting around Saturn is basically a loaded gun pointed at the system's most interesting moons. 2 of them, Enceladus and Titan, might have the right conditions for life. If Cassini ran out of fuel and eventually crashed into one of them, it could contaminate them with Earth microbes that had been riding along since 1997. Scientists weren't willing to take that risk. So instead of letting Cassini die randomly, NASA decided to control exactly how, when, and where it would end, and to make that ending scientifically useful. If you enjoy stories about the engineering decisions behind real space missions, subscribing helps this channel keep making them. The Grand Finale: 22 orbits between Saturn and its rings. NASA's plan was called the Grand Finale. Between April and September 2017, Cassini flew 22 orbits through a gap that had never been touched by any spacecraft before: the narrow space between Saturn's cloud tops and the inner edge of its rings, about 1,500 miles wide. Engineers had modeled the region carefully using years of data, and everything suggested it was likely to be relatively clear. But until Cassini actually flew through it, nobody could be completely certain. There was still a real risk that unseen dust or ring particles could damage the spacecraft on the very first pass. It turned out to be far emptier than expected, which was itself a small discovery nobody had been sure of going in. Why these orbits mattered. Here's why NASA was willing to risk an entire spacecraft to fly through that gap. Cassini was now closer to Saturn than any spacecraft had ever been while still transmitting data. That proximity let scientists do something they couldn't do from a normal orbit, using Cassini's own radio signal to measure tiny variations in Saturn's gravity field, sensitive enough to reveal clues about what's happening deep inside the planet. At the same time, Cassini was flying directly through the gap between the rings and the atmosphere, sampling the actual particles and charged material in that space. None of this was possible from a distance. The Grand Finale wasn't just a dramatic ending, it was the closest look at Saturn's environment that any mission has ever managed to take. But Saturn wasn't finished surprising Cassini. One of its strangest secrets was already waiting above the North Pole. The hexagon wasn't new. Voyager had already spotted this 6-sided jet stream circling Saturn's North Pole back in the 1980s. But Cassini spent years watching it up close, and its final, highest-resolution observations revealed just how strange this storm really is. Sharp, stable edges that have held their shape for decades, made entirely of moving gas. Scientists have recreated hexagon-shaped currents in lab tanks of spinning fluid, so we have a rough idea of the physics involved. But that only tells us the shape is possible. It doesn't explain why Saturn is the only planet we know of where it actually happens or why it's lasted this long. That part is still genuinely unresolved. The invisible Saturn. Some of Cassini's most important discoveries during the Grand Finale weren't things you could see at all. Saturn has a powerful magnetic field, generated deep inside the planet. During its final orbits, Cassini flew closer to that field than any spacecraft ever had, measuring it directly instead of from a distance. Combined with the gravity measurements from Section 3, this data let scientists start piecing together clues about Saturn's interior, things like how its atmosphere interacts with the deeper layers below, and how uniform or uneven the planet actually is underneath its clouds. None of this showed up in a photograph. It came from instruments reading invisible fields and forces that cameras can't capture, which is exactly why getting this close mattered so much. Ring rain, Saturn is losing its rings. While flying through the gap, Cassini also measured something scientists had suspected but never confirmed precisely. Material from the rings was raining down into Saturn's atmosphere, a phenomenon now nicknamed ring rain. Based on the rate Cassini observed, the visible rings could be lost on a timescale of hundreds of millions of years, though scientists still debate exactly how fast that process is happening, and how old the rings even are to begin with. Some estimates suggest they could be far younger than Saturn itself, meaning the rings we see today might not be a permanent feature at all, but a relatively temporary phase the planet is passing through. And if you think Saturn's rings are just permanently going to be there, keep watching, because what happens deeper inside the planet is even harder to explain. If you enjoy stories where science overturns what we thought we knew, consider subscribing to this channel that covers discoveries exactly like this one every week. The fuzzy core. But the rings weren't the biggest surprise. The most important discovery was buried far deeper beneath hundreds of miles of atmosphere. Before the grand finale, scientists generally pictured Saturn's interior in fairly simple terms: layers of hydrogen and helium wrapped around a distinct, compact core. The gravity measurements Cassini collected during its final orbits were precise enough to challenge that picture. The data instead pointed toward what scientists now describe as a fuzzy core, a region where heavier elements appear to blend gradually into the surrounding hydrogen and helium, rather than ending in a sharp boundary. In other words, one of Cassini's last contributions was forcing scientists to redraw the inside of an entire planet. Cassini's final data. By this point, Cassini wasn't just running out of fuel, it was running out of time, and its last act wasn't simply to fall. As Cassini began its final descent into Saturn's atmosphere on September 15, 2017, it kept its instruments running and kept transmitting. It wasn't just dying. It was still working, measuring the composition of the upper atmosphere directly, in real time, as no spacecraft ever had before. Every second it survived on the way down gave scientists another measurement, right up until the atmosphere became too thick for it to continue. The final image. The day before that final plunge, on September 14, 2017, Cassini pointed its wide-angle camera at the spot in Saturn's atmosphere where it was about to end its mission, and took its last photograph. It wasn't dramatic, just a patch of clouds lit by the sun on the night side of the ring's shadow. No fireworks, no countdown graphics, just Saturn looking back at the spacecraft that had orbited it for 13 years with no idea anything was about to end. The next day, Cassini entered Saturn's atmosphere at over 70,000 miles per hour, burning up as it went, briefly becoming an artificial meteor in the planet's sky. It kept transmitting data the entire way down until the heat and friction finally tore the antenna out of alignment with Earth. Then, mid-signal, there was silence. Here's where it gets a little poetic. A spacecraft that spent 13 years teaching us what Saturn is, its rings, its storms, its magnetic field, its fuzzy, mysterious core, didn't just end its mission when it ran out of fuel. Cassini's remains were ultimately absorbed into Saturn's atmosphere. A spacecraft that spent 13 years studying Saturn had finally become part of the planet itself. And somewhere up there right now, that hexagon is still spinning, the rings are still quietly raining down, and Saturn is still keeping secrets that took a spacecraft's entire life and death to even start uncovering. If you want more stories like these missions that ended in ways that reshaped what we know, subscribe and turn on notifications, because this is exactly the kind of story we cover every week.